is posterior fossa cisterns. Dr. Oswin is Air Force resident at Liaquat National Hospital. The expert panelist today is Dr. Mohammad Yasin. Dr. Mohammad Yasin is consultant neurosurgeon at Patel Hospital and has been. And I welcome Dr. Yasin to this session. Dr. Oswin will present his presentation and followed by expert views and maybe Dr. Yasin will share some cases. I urge you to all get involved, ask questions, and so because these sessions are for you. Dr. Oswin, can you start?
Okay, sir. So good morning. So today's topic of our discussion is the post-fossa cistern. The subarachnoid space situated between the pia mater and the outer arachnoid membrane expands at the base of the brain around the brainstem and the tentorium insula to form a compartment filled with cerebrospinal fluid. These spaces have numerous trabecular septas and membrane crossing the space between the pia and the outer arachnoid membrane to divide the subarachnoid space into smaller compartments, which are called the cisterns. All the cranial nerves and the major intracranial arteries and the vein passes through these cisterns. Cisterns are the opening in the arachnoid space of the brain created by the separation of the arachnoid and the pia mater. These spaces are filled with the CSF, and the cistern provide a natural pathway through which the most operation of the intracranial aneurysm, extra axial brain tumors, and the disorder of the intracranial nerves are directed. Some cisterns have sheet-like membranes, whereas the other indistinct porous trabeculated walls within the opening of the various eyes. So as we can see in this figure, there's a space anterior to the peduncles, which is the interpeduncular space. The space between the clivus upper portion and the pons is the prepontine cistern. The space between the lower part of the cistern clivus and the medulla is the pre-medullary cistern. The lateral to the prepontine cistern is the cerebellopontine cistern, and the lateral to the premedullary cistern is the cerebellomedullary cistern. Posterior to the medulla brainstem and the occipital bone is the cisterna magna. Superior to the tentorium and the interior pineal region is the quadrigeminal cistern. The subarachnoid cisterns are divided into supratentorial and the infratentorial group. The cisterns located in the post fossa or that communicate through the tentorial insula are described here. They include paired and the unpaired cistern. The unpaired cistern are the intrapeduncular cistern, the prepontine, the premedullary, the quadrigeminal, and the cisterna magna, whereas the paired cistern are the cerebellopontine and the cerebellomedullary cistern. This is the mid-sagittal cut, a schematic diagram in which we can appreciate this brown-colored area, which is a cone-shaped structure, is the intrapeduncular cistern. Anterior to which is the chiasmatic cistern, whereas the posterior is the midbrain, is the and in between the interpeduncular of the midbrain. Below is the blue color structure, which is the pre-pontine cistern. It is situated between the upper portion of the clivus and the posterior to it is the pons. Inferiorly is the pink color, which is the premedullary cistern. Posteriorly is the cisterna magna. Superiorly is the this brown color structure is the superior cerebral cistern, and the quadrigeminal cistern, which is the green color. In this session, we will be discussing about these cisterns. This is the anterior view in which the arterial as well as the nerves structures passing in this cistern are easily visualized. Like as we can see in the this pink color area, which is the premedullary cistern, the two vertebral arteries which ascend upwards in the premedullary cistern, and at the tip where the premedullary and the prepontine cistern are linked is the space where the basilar artery arises, and the basilar artery ascend upward in the prepontine cistern and divides into the superior cerebellar and the posterior cerebellar artery, and which is in the interpeduncular cistern. Lateral to the prepontine cistern is the cerebellopontine cistern, and lateral to the premedullary cistern are this yellow area, which is the cerebellomedullary cistern. As we can see, this in the midline is the unpaired cistern, which is the interpeduncular, prepontine, and the premedullary, whereas the lateral are the paired cistern, which is the cerebellopontine and the cerebellomedullary cistern. Also, we can visualize that the in this interpeduncular cistern is the third cranial nerve, which is the content of the interpeduncular cistern. The in the prepontine cistern there is no nerve passing, whereas in the cerebellopontine superiorly is the superiorly is the trigeminal, in just lateral to the prepontine, and the inferior is the abducent, which is the sixth, and the complex of the vestibular, cochlear, and the seventh nerve. In the cerebromedullary cistern, upper is the glossopharyngeal, which is the ninth. The 10th is the vagus, and the 11th, which is the accessory nerve passing in the cerebromedullary cistern. Here we can see the lateral view of the same area, in which the cerebellopeduncle, interpeduncular cistern, the prepontine, and the premedullary cistern are shown with its relationship with the arteries and the nerves. We will be discussing in detail in upcoming slides. This is the inferior view, in which we can see the large area, which is the inferiorly is the cisterna magna. Anteriorly is the cerebromedullary cistern. Anterior to the cerebromedullary cistern is the cerebropontine cistern, and in the midline is the premedullary and the prepontine cistern. So most of the it is a very important slide in this presentation, and most of the structure are easily visualized in this slide. This is the anterior-inferior view of the brain, in which the arachnoid on the one half is preserved, and on the other half, the arachnoid layer has been removed to show the cistern and the membrane in between the cistern, traveling and which is dividing the cistern into compartments separately. So anteriorly, as we can see, this is the internal carotid artery. And medial to the internal carotid artery is the medial internal carotid membrane, which separates the chiasmatic cistern from the carotid cistern. Lateral to the carotid cistern is the lateral carotid membrane, which marks the lateral limit of the carotid cistern. Inferior to the carotid cistern is the ambient cistern, which is present inferiorly inferior to the carotid cistern, and as we see in the midline, there's this area which is present in between the medial carotid membrane is the chiasmatic cistern. The chiasmatic cistern posteriorly separates from the interpeduncular cistern by a membrane called the Lilliquist membrane, which divides into two membranes. The deep or the dense membrane is the diencephalon membrane, whereas the thinner membrane is the mesencephalic membrane. As we can see, this structure is the mesencephalic, whereas this membrane is the diencephalic membrane. This diencephalic membrane separates the chiasmatic cistern from the interpeduncular cistern, whereas the mesencephalic membrane separates the interpeduncular cistern from the prepontine cistern. Prepontine cistern is present anteriorly to the pons, and and it is separated from the cerebropontine cistern by a membrane, which is which you can see over here is the anterior pontine membrane on both sides. This anterior pontine membrane runs from extend from this oculomotor nerve down to the area where it is present laterally, medially to the abducent nerve. It laterally to the prepontine cistern, we can easily visualize this area, which is the cerebropontine cistern. Below the prepontine cistern is the pre-medullary cistern. This pre-medullary cistern is separated from the prepontine cistern by a thick tabulated structure, which is the median pontomedullary membrane. This median pontomedullary membrane is thickened around the basilar artery to prevent any other structure passing from this area. Only the basilar artery passes through this area. Also, it is at the level of the where the pons communicate with the medulla. Um, Lateral to the premedullary cistern is the cerebromedullary cistern. This cerebromedullary cistern is separated from the prepontine cistern by a thick trabeculated structure, which is densely adherent to the inferior olive of the medulla. The artery and the venous structure we will be discussing in the upcoming slides. So, Lilliquous membrane is the arachnoid membrane separating the chiasmatic cistern from the interpeduncular cistern and the prepontine cistern, as we have already discussed. This area, it arises anteriorly from the diaphragmatic sella and extends posteriorly, separating the two sheets. One extends posterior superiorly to the posterior edge of the mammillary bodies, which is known as the diencephalic membrane. It separates the chiasmatic cistern from the interpeduncular cistern. The second sheet extending posterior inferiorly to the mesencephalic junction, also known as the mesencephalic membrane, it separates the interpeduncular cistern from the prepontine cistern. The lateral edges of the diencephalic and the mesencephalic membrane attaches to the arachnoid sheet around the oculomotor nerve. The diencephalic membrane is thick of the two and is more frequently without any perforation, so it acts as a barrier to the passage of the air and the other substance through the subarachnoid space. The mesencephalic membrane is the thinner and more frequently incomplete and contained in an opening through which the basilar artery ascends into and reaches the interpeduncular fossa. As we can see in this figure, this membrane, which is adherent to the dorsum sella, as it passes posteriorly, it along the oculomotor nerve, it intersects and divides into two membranes. The upper leaf, which is the diencephalic membrane, diencephalic leaf, which is in blue, which you can see is the blue color area. It passes superiorly and it adheres to the diencephalon area as well as the posteriorly to the mammillary bodies. Whereas this structure is thickened and it separates the chiasmatic cistern from the interpeduncular cistern. And the second membrane, which is the mesencephalic membrane, it curves on the oculomotor nerve, and it connects. It is adherent to the area where the pons is communicate with the midbrain. This is another figure in which we can easily visualize the lilliquid membrane separating into two leaves. The outer leaf, the upper leaf is the diencephalic membrane, whereas the lower leaf is the mesencephalic membrane, which adhere to the superior cerebral artery, and it curves on the oculomotor nerve. And we can also see that this diencephalic membrane separate the chiasmatic cistern from the interpeduncular cistern, and the interpeduncular cistern is separated from the prepontine cistern by a membrane, which is the mesencephalic membrane of the lilliquous membrane. On an MRI, it is visualized like this densely dense, hyperintense, hypointense structure is the diencephalic membrane, whereas this lighter structure below it is the mesencephalic membrane. So the interpeduncular cistern is a cone shape. It is situated between the cerebral peduncle and the leaves of the liqueous membrane. The confluence of the it is at the confluence of the supra and the infratentorial part of the subarachnoid space. The posterior wall of the cistern is formed by the posterior perforating substance. The upper border is situated posteriorly to the edge of the mammary body. The lower border is situated at the junction of the midbrain and the pons. It is also bordered rostally and caudally by the liqueous membrane. This is the anterior inferior view in which we can see the mammillary bodies present over here and the basilar artery which ascending upward from the pons up to the level of the interpeduncular fossa and is divided into the terminal branches into the which is the posterior cerebral and the superior cerebral artery. In between the posterior cerebral and the superior cerebral artery is the nerve running in between is the oculomotor nerve. Also, these the interpeduncular fossa is also supplied by the uh, um, median thalamoperforating arteries and also the veins. This is also an anterior inferior view in which we can visualize the mammillary bodies over here. This is the chiasmatic cistern, and in between the chiasmatic cistern and the interpeduncular cistern is a thin liqueous membrane. Over here, it is the diencephalic membrane, whereas in between the diencephalic and the lower portion is the membrane which is separating the interpeduncular from the prepontine is the mesencephalic membrane. These membrane, the diencephalic and the mesencephalic membrane, on the lateral edges communicates uh, and covers the third nerve, which is the oculomotor nerve. The oculomotor nerve has an important value in this figure, as we can see the oculomotor nerve traveling from the interpeduncular cistern up to the ambient cistern, which is the area in between uh, the carotid cistern. The below is the Cerebellopontine cistern. Medially is the Prepontine cistern, and upper is the interpeduncular cistern. And we can see over here, superior medially is the chiasmatic cistern. This oculomotor nerve is in between these all cistern cavities. So the content of the interpeduncular cistern is the bifurcation of the basilar artery, as we have seen, the posterior cerebral artery, the superior cerebral artery, the basal vein of the rosenthal, the interpeduncular veins, and the posterior communicating veins. The third nerve, which is the oculomotor nerve, traveling in the lateral wall, passing between the posterior cerebral artery and the superior cerebral artery, as we have discussed. So on an MRI, this is the sagittal and the axial cut. As we can see, the space over here in at the midbrain and anterior to the chiasm is the interpeduncular cistern. Next is the prepontine cistern. The prepontine cistern lies between the arachnoid membrane, which rests on the clivus, and the anterior surface of the pons, as we can see over here. The prepontine cistern is separated from the interpeduncular cistern by a mesencephalic leaf of the liqueous membrane, as we have already discussed. The lateral edges of the prepontine cistern are separated from the cerebellopontine cistern by a paired anterior pontine membrane. This anterior pontine membrane, which crosses between the interval from the pons and the outer arachnoid membrane that rests on the clivus. The anterior pontine membrane intersects the oculomotor nerve superiorly and extend downward along the medial side of the abducent nerve. The anterior pontine membrane becomes progressively thinner as they extend caudally and may disappear in the lower pons. This is anterior inferior view in which we can see the prepontine. cistern. Uh, Prepontine cistern. The upper is the mesencephalic leaf, which separate the prepontine cistern from the interpeduncular cistern, and lateral to the prepontine cistern is the cerebropontine cistern, which is separated by a paired membrane, which you can see over here is the anterior pontine membrane. The content in the prepontine cistern is the um, basilar artery. The basilar artery, as it ascends upward, it gives branches. The first branch which it gives in the prepontine cistern is the anterior cerebral artery, and which you can see over here, the anterior cerebral artery, and the perforating pontine branches. Superiorly, at the upper edge, it gives a superior cerebral artery and the posterior cerebral artery. In this figure, we can see the prepontine cistern and its relationship with the lateral pontine cistern. Sorry, cerebropontine cistern. The cerebropontine cistern is separated from the ambient cistern by a membrane, which is the lateral pontomesencephalic membrane, as we can see over here. This lateral pontomesencephalic membrane is present inferior to the superior cerebral artery and separates the ambient cistern from the from the cerebropontine cistern. Also, we can see that this area is the interpeduncular cistern, from where the basilar artery bifurcates into the posterior cerebral artery and the superior cerebral artery, which is running in between this structure. This is the lateral perspective of the mid basal artery and the prepontine cistern. This is the prepontine area. Over here, this area is the pons, and the interior, this bony structure is the clivus. We can see this is the mid basilar artery. From there, the anterior inferior cerebral artery is arising and is bifurcating into the caudal, rostral, and the caudal trunk. Between the rostral and the caudal trunk, this nerve which is passing through is the abductor nerve, and over here is this structure is the trigeminal nerve. These are the superior petrosal veins which drain into the superior petrosal sinus. The content of the prepontine cistern is the basilar artery and its origin and the origin of the anterior inferior cerebral artery. There is no nerves passing in between the um, prepontine cistern. The transpontine vein and the anterior pontomesencephalic membrane veins are also the content. On an MRI, the prepontine area we can see on the sagittal as well as in the axial cuts. This area, the space between the pons and anterior clivus, is the prepontine cistern. Then is the cerebropontine cistern. The cerebropontine cistern lies between the anterolateral surface of the pons and the cerebellum and the arachnoid membrane that rests on the posterior surface of the petrous bone. Superiorly, at the level of the tentorium, this cistern is separated from the ambient cistern by the lateral pontomesencephalic membrane, as we have already seen. Inferiorly, the cerebropontine cistern is separated from the cerebromedullary cistern by the membrane, which is the lateral pontomedullary membrane, which crosses the subarachnoid space between the vestibulocochlear and the glossopharyngeal nerve. Medially, the cerebropontine cistern separate from the prepontine cistern by a membrane, which is the anterior pontine membrane. Laterally, the cerebropontine cistern extend into the edges of the cerebral surface that wraps around the pons to form the cerebropontine fissure. So in this figure, we can see this area, which is the prepontine cistern, and laterally is the cerebropontine cistern. In the Cerebellopontine cistern, we can see at the lower edge is this structure nerve which is passing upward is the abducent nerve. More lateral to the abducent nerve is the vestibular cochlear complex and the facial and the seventh nerve, which is the facial nerve. Superior laterally is this structure which is passing is the fifth, which is the trigeminal nerve. In the Cerebellopontine cistern, there's an artery which starts from the Prepontine. It passes through the anterior perforating anterior pontine membrane and reaches to the Cerebellopontine cistern by passing through the anterior pontine membrane. Superiorly to the Prepontine Cerebellopontine cistern is the superior cerebral artery, which divide into the rostral as well as the caudal trunk. This superior cerebral artery can be divided either in the Prepontine or in the Cerebellopontine cistern. The laterally, as we go laterally, this Cerebellopontine cistern, it communicates with each other and at the level of the cerebellomedullary fissure and from the cerebellomedullary fissure. This is the retrosigmoid approach in which the dura has been separated, and the as we can see this membrane structure which separates the cerebellopontine cistern from the cerebellomedullary cistern. This structure passing through from the folliculus up to the lateral edges of the cerebellopontine cistern. Also, the nerve which passes below is the glossopharyngeal nerve, and the superiorly is the vestibulocochlear complex. This membrane is which separates the cerebellopontine cistern from the cerebellomedullary cistern has an important relationship as it divides the two compartments. Also, the articular structure which passing from below is the pica, which perforate this structure and passes into the posteriorly. We can see the structure passing anteriorly to the medulla is the vertebral artery. This vertebral artery anteriorly communicates and form the basilar artery, from where it give branch to the pica and from in the cerebellomedullary cistern, and from the cerebellomedullary cistern and the pica, which travel posteriorly in the dorsal region of the medulla and goes posteriorly up to the cerebral hemisphere. Also, we can see in this area is the transpontine membrane nerves, and the superior petrosal veins, which drain into the superior petrosal sinus, and the structure which and the nerves which passing in the superior in the cerebellopontine cistern is the first is the vestibulocochlear. And then this is the we can see over here is the sixth, which is the abducent nerve. And below is below the vestibulocochlear is the seventh nerve, which is the facial nerve. This is the similar structure as we can see the choroid plexus, which passes through the foramen lusca, and the membrane which passing from the foramen lusca up to the lateral margins of the cerebellopontine cistern separates the two cistern from cerebellopontine and the cerebellomedullary cistern. Below this lateral, below the lateral, below the below to, below this membrane is the glossopharyngeal nerve and the 10th, which is the vagus nerve, and the 11th, which is the spinal accessory nerve. This is the similar picture taken from the roton, in which we can see the flocculus, the choroid plexus, the 7th and the 8th cranial nerves. Below is the glossopharyngeal, the vagus, and the 11th cranial nerve. Over here we can see the basilar artery. Below is the vertebral artery, which joins and form the basilar artery, and posteriorly is this branches from the which is arising from the pica. So the content of the Cerebellopontine cistern is the seventh, eighth, the fifth, which is a trigeminal, anterior inferior cerebral artery, the lateral pontine veins, superior petrosal vein. On an MRI axial cut, the Cerebellopontine cistern can be visualized over here. So the premedullary cistern, which lies between the anterior surface of the medulla and the arachnoid membrane covering the lower part of the clivus. Its upper border is located at the junction of the pons and the medulla. It's separate from the prepontine cistern by a median pontomedullary membrane. Laterally, its border with the cerebromedullary cistern. Inferiorly, the premedullary cistern is continuous with the anterior spinal cistern. This is the anterior inferior view in which the venous complex can be seen. In this figure, the area over here is the prepontine, and below it is the premedullary cistern. Both these structures are separated by a thick trabeculated membrane, which is the median pontomedullary membrane, and we can see over here it is trabeculated and it covers densely around the basilar artery. Basilar artery is not shown over here, but this is the median anterior pontomesencephalic membrane vein. Lateral to the premedullary cistern is this area, which is the cerebromedullary cistern, and this trabeculated trabeculus, which we can see over here, separates the premedullary cistern from the cerebromedullary cistern. This is another view in which we can see the arterial structure passing from the premedullary to the prepontine cistern. As we can see, the vertebral artery anterior to the medulla joins to form this basilar artery, and there's a trabeculus which we can see over here is densely adherent to the basilar artery. Also, this arteries which arising from the basilar artery is the posterior inferior cerebral artery, the anterior inferior cerebral artery, which runs from the prepontine and the premedullary cistern into the cerebropontine and the cerebromedullary cistern. So the content of the prepontine cistern are the vertebral arteries, the posterior inferior cerebral arteries, the anterior spinal artery, which as you can see over here, the vertebral artery from both sides and the give branch, which is the spinal artery, anterior spinal artery, which communicates with each other and form a main trunk supplying the anterior surface of the spinal cord, and the premedullary veins, and the 12th, which is the hypoglossal nerve. On an MRI, the premedullary cistern can be visualized like this. Then we have the cerebromedullary cistern. The cerebromedullary cistern, which lies at the caudal to the junction of the pons and the medulla, it's separate from the cerebropontine cistern by a membrane, which is the lateral pontomedullary membrane, and from the premedullary cistern by a trabeculus in front of the glossopharyngeal and the vagus and the accessory nerve. The inferior border is located at the level of the foramen magnum. The cistern extends backward from the dorsal margin of the inferior olive around the dorsal lateral medulla to the biventral lobules of the cerebellum. The lateral recess of the fourth ventricle, which communicates with the cistern through the foramen lusca. The choroid plexus that projects from the foramen lusca is the site of the posterior surface of the glossopharyngeal and the vagus nerve. Over here, we can visualize the lateral surface of the where we can see the pons and the medulla. This area is the cerebropontine area, whereas below is the cerebromedullary cistern. Both of these structures are separated from each other by a membrane, which is the lateral pontomedullary membrane, which is excised over here. This membrane separates the vestibulocochlear complex from the glossopharyngeal nerve. As we can see, the two structures are separated from each other. Also, the vestibulocochlear nerve um, posteriorly to the foramen luschka, from where the uh, choroid plexus arises and enters into the cerebropontine cistern. Over here, the hypoglossal nerve has been dissected. This nerves, which we can see over here, is the uh, accessory nerves, and this nerve, which is present posteriorly, is the abducer nerve, which is traveling upwards, and this bunch of nerve, which is the trigeminal nerve, we can see over here. The similar structure we can see in the pica, which runs from the prepontine and the premedullary into the cerebromedullary cistern. We can see that this figure is start from the premedullary cistern, and it travel posteriorly into the cerebromedullary cistern. So the content of the medullary cistern are the 9th, the 10th, the 11th, the vertebral artery, the posterior inferior cerebral artery, the lateral medullary, and the posterior olivary veins. So on MRI, the cerebromedullary cistern can be visualized like this, as we can see over here. This area is which is the hyper intense area seen over here is the cerebromedullary cistern. The cisterna magna, which is the largest of the subarachnoid cistern, the cisterna magna lies dorsal to the medulla and the cerebellar vermis. The posterior wall is formed by the arachnoid membrane that form to the inner surface of the occipital bone above the foramen magnum. Its characteristic features of the cisterna magna is that it is dense, mesh-like trabecular arachnoid that extend from the cerebellar tonsil to the medulla and the margin of the foramen magnum. Superiorly, the cisterna magna projects both anteriorly and posterior to the cerebral vermis. Anteriorly, it opens into the cerebromedullary fissure. Cisterna magna also open behind the vermis into the posterior cerebellar insula. The upper limit of the extent behind the vermis is the tentorium. Inferiorly, the cisterna magna communicates without any obstruction with the posterior spinal cistern. As we can see in this figure, the anteriorly, the cisterna magna communicates and ends into the cerebromedullary fissure. Posteriorly, it runs upwards and up to the cerebral vermis. Inferiorly, it communicates through into the posterior spinal cistern. Anteriorly, it is present the posterior surface of the medulla, and posteriorly, it is communicate with the arachnoid which rest on the occipital bone. The content of the cisterna magna, which is the posterior inferior cerebral artery, the glossopharyngeal nerve, the vagus, and the spinal accessory nerve. The cisterna magna on an MRI, which can be seen like this. The quadrigeminal cistern is enclosed space that correspond to the pineal region. The quadrigeminal plate is located at the center of the anterior wall of the cistern. In the midline, the anterior wall uh, rostral to the collicula is formed by the pineal gland. Laterally, the anterior wall is formed by the part of the pulvinar that lies medial to where the crust of the fornix wraps around the pulvinar. The medial half of the pulvinar form the anterior wall of the cistern, and the lateral half of the pulvinar form the anterior wall of the atrium of the lateral ventricle. Each lateral ventricle, each lateral wall of the cistern has anterior and the posterior part. The anterior part is formed by the segment of the crus of the fornix that wraps around the pulmonar, and the posterior part is formed by the part of the occipital cortex located below the splenium. Below the colliculus, the cistern extend into the cerebromesencephalic fissure. And this is the superior view in which we can see this highlighted area, which is the quadrigeminal cistern. Superior to the quadrigeminal and superior anteriorly to the quadrigeminal cistern is this area which is the ambient cistern. From here we can see the pica, which is running in from the PCA, which is running from the ambient cistern into the quadrigeminal cistern, giving its branches. Below over here is the superior colliculus as well as the inferior colliculus. Over here is the pineal gland. This basal the nerve complex, venous complex, which we can see over here is the uh, vein of Galen. Over here, which we can see is the veins which run from the vein of Galen over here, as well as below is the internal cerebral internal cerebral vein, and over here this complex which form the confluence and opens into the splenium into the superior straight sinus. Sorry. This structure over here, which is the pulmonar which is divided by the crust of the fornix into the ventricular part as well as the cisternal part. The ventricular part, which form the anterior wall of the quadrigeminal cistern, and the ventral part, which form the anterior wall of the atrium of the lateral ventricle. This is also the superior view in which we can see the splenium over here, the pulmonar, the quadrigeminal cistern, and the articular and the well as the venous structure passing in between this area. This is the interhemispheric view of the quadrigeminal cistern and the quadrigeminal plate. This is the splenium from where the posterior pericallosal vein is communicating with the draining into the vein of Galen. This below vein is the internal cerebral vein. This structure over here is the uh, parieto-occipital veins, which drain into the vein of Galen and which ultimately drain into the straight sinus, as we can see over here is the straight sinus. This highlighted structure over here is the quadrigeminal cistern, and over here these are the branches from the posterior cerebral arteries and the superior cerebral arteries supplying this structure of the quadrigeminal cistern. In this figure, we can visualize the vein of Galen, which ultimately drain into the straight sinus. The vein of Galen is drained by the basal vein, the superior vermine vein, the basal vein from the other side, and the other vein, which is the uh, anterior calcarine vein, which drain from the vein of Galen. So contain are the posterior cerebral arteries, the posterior choroidal arteries, the superior cerebral arteries, the trochlear nerve, which arises from the inferior olivary nucleus, passing anteriorly into the midbrain and travels into the ambient cistern. The venous confluence at the junction of the vein of Galen, inferior sagittal sinus, and as well as the straight sinus are the content of the quadrigeminal cistern. On an MRI, the quadrigeminal cistern can be visualized like here, which the arrow which are pointing. Last is the superior cerebral cistern. This cistern is situated between the superior part of the vermis and the arachnoid membrane that rests against the lower border of the straight sinus. Anteriorly, it opens into the quadrigeminal cistern. Posteriorly, it communicates below the trochlea with the cisterna magna. Laterally, it blends into the subarachnoid space over the cerebral hemisphere. This brown area, which is the superior cerebral cistern, as we can see in this figure. The content of the superior cerebral cistern is the median and the paramedian branches of the superior cerebral arteries, as well as the superior vermian vein. On an MRI, the superior cerebral cistern can be visualized like this.
Thank you, Dr. Oswin, for such a detailed presentation illustration. It was a big presentation. It was a big topic, and you covered it very well. And can you please make Dr. Yasin co-host so that he can? Yes, Dr. Yasin is co-host now. So now I will ask Dr. Yasin to give his expert opinion and maybe share his cases. Dr. Oswin, can you stop sharing so that Dr. Yasin can share his presentation?
Yes, sir.
Dr. Yasin, can you share your presentation, please?
Good morning, everyone, and thank you, Oswin. I think it was an excellent presentation. I hope you guys can hear me. So, can you see my screen?
Not yet. We're still waiting for it to share.
So, meanwhile, while we set it up, I will just say a few comments. I think it was an excellent presentation. The things that I would like to highlight is when we're in the operating room and we're there in the surgery and we're operating on these patients and these systems, to really identify them and how to dissect them is what I'll be just touching upon. I know it's a long topic. I will.
Dr. Yasin, there's something. I think there's something wrong with your mic. There's an echo or some disturbance while you speak.
I just. Just wait. Okay. Can you hear me now?
Yeah, we can hear you now, but we still haven't. Your screen is not sharing.
They have they made me the host? Yeah. Okay. Right. So
Yes, it's shared.
now it's here. Okay. So I will share two cases. One is a very simple and a classic case of left CT angle mass. This is a 51-year-old lady who came into the clinic with a history of headache and tinnitus and hearing loss. So this is a T2 axial image showing a mass lesion within the CT angle system, right, which is slightly isointense to hyperintense. The point I want to make is how will you approach it and how will you open these systems. Once you've done the retrosigmoid craniotomy and you open the data, the first thing you encounter is the cerebellum. To approach the cisterns, for example, the cerebellomedullary cistern and the Cerebellopontine cistern and the Cerebellomedullary cistern, first, the point is how to retract the cerebellum. If you retract the cerebellum from the superior lateral aspect, you will encounter the petrosal vein first, which obviously you can save or you can coagulate. But the important point is to open the arachnoid spaces, the arachnoid systems, that will help you in first draining the CSF, which will relax the cerebellum and the hemispheres. So it will give you more space to retraction and the visualization will be improved. Second, Once you dissect these cisterns and the arachnoid membranes, you're releasing the vessels and the nerves from the traction that you put in during your retraction. So these structures can be saved. So you can see this image that it's occupying the whole cerebellopontine angle cistern, and it's going to the lateral pontine angle cistern as well. I hope everyone can hear me and understand.
So, Dr. Yasin, one of the participants, Dr. Pravat, is asking which cisterns we have to open to drain some CSF while doing CP angle. So I think that has already been explained by Dr. Osman, that we open up the Cerebellopontine cistern and the Cerebellomedullary cistern if required. Some people even go and open up the Cisterna magna as well. So these are the three cisterns that you will face while doing a CP angle tumor. Do you agree, Dr. Yasin?
Yes, the point is once you retract the cerebellum, you will see the arachnoid membranes. As Dr. Saad rightly pointed out, some people with large tumors, they will just go down and just puncture the arachnoid over the cisterna magna to drain the CSF first. And then they will, once the CSF drainage is done, the cerebellum is much more relaxed. And then you retract your cerebellum, and then you progressively open the cisterns by cutting the arachnoid membranes. The important point about cutting the arachnoid membranes is you cut them sharply with the sharp scissors so that they can retract, and you don't put excess tension on it. Some people will try to use a nerve hook and pull them. I would suggest, and many of the surgeons would do sharp dissection and cut these arachnoid membranes. And one of the tricks is to cut the arachnoid membranes and to cut the arachnoid adhesions in the line of the nerves, so that they will relax and you don't injure the nerves.
Dr. Yasin, can you show your second case as well, please?
So this was a case of a CP angle tumor, a classic CP angle lesion, most likely an acoustic neuroma, and the simple operative terms. The second case is an unusual one. I wanted to just put this case just to have an idea about unusual lesions and how to approach them, and what possible difficulties you might face while approaching these sort of lesions. So this is a lesion which seems to be located posteriorly in the midbrain.
Dr. Yasin, your slides have not changed. Can you please, if it's in full screen, can you go off full screen? Because I think Zoom has issues when you go on presenters mode or the slideshow.
Great.
Can you change your slides now?
The slides are.
You don't have to put slideshow, just show the, if you can change your slide.
Can you see my slides now?
We can see the slide, but they're not changing.
Okay.
Yeah, it's changed. It's changed now. Can you show the Excel view? And since we're just at the end of our we're stretching our time limit, you don't have to go to full screen. We just do the last case and then we'll finish.
This is the last case. This is another patient with a mass. You can see the mass on the exit section is in the midbrain, but it's projected posteriorly. So just to put this case and just to have an idea of how to approach this lesion can be approached via infratentorial supracerebral approach. And the two important cisterns that will come in your way will be the first, the superior cerebellar cistern, and the second will be the quadrigeminal cistern. So, as we described, the quadrigeminal cistern and the arachnoid membranes of the quadrigeminal cisterns are generally very thick. And as we discussed, the confluence of the veins and the vein of Galen would be in your way before you reach the lesion. So again, the art is one, the release of CSF, two, sharp adenoidal dissection to move the veins out of your way, and then to approach this lesion. Any comments, sir?
No, sir. You did a supracerebellar infratemporal approach for this case.
Yes.
So, excellent cases, Dr. Yasin, and I thank you for joining us. Since we're already stretching and at the end of our time, I thank you all for joining. I thank Dr. Yasin for coming and giving his expert opinion and sharing his two cases. We'd like to conclude the session today. We'll see you all next week. Thank you, Dr. Yasin, for joining. Thank you for giving us time. We'll bug you in the future as well for future sessions as well.
Thank you, sir. Thank you so much.
Thank you for. See you all next week.